My name's Sam Parnell, and I chair a committee called the Ipswich and Suffolk Tech Network. We are an umbrella organisation, and we sit over a load of community meetups, and the topics are anything from digital marketing, so small business education, right the way through to IoT, and it loops in telco. We're near Adastral Park in Martlesham, which is where Paul's based. Ipswich is very close to that, so obviously telco and everything around it from software development is a big thing in our environment, and it comes out into the community, which is lovely. So a lot of the reason that we run these events is so that there's one portal. I'll drop the link for the ISTN into the chat for you, and you can see this swathe of different talks. And as Paul mentioned, with the popularity of this talk, we're very keen to run more on a similar subject and run a kind of stream of them in the background. And again, if any of you would like to pitch to talk, and on top of that, if you've got any suggestions of talks that you would like, the community that we run is run for the community. That's its literal purpose. So if there's something that you want to know about, and again, an executive who wants to know more about LinkedIn marketing, speak to us. We can do that in one of our events. So that's what we're here for. So I'm going to pass over to Paul Graham, who I think some of you know, but he'll introduce himself. Paul will explain. He's looking for questions at the end, dropped in chat. So feel free to communicate via chat, as I know you will. But if you can keep questions till the end so that Paul can read through and answer any that arrive then. I'm going to pass you over. Excuse my voice. I'm going to pass you over to the lovely Paul Graham. Here you go, Paul.
Thank you, Sam. Well, welcome everybody. It's good to see so many people here. Quite a spread really of local people, plus people further afield and people I've worked with and continue to work with. So I welcome all you all. This is Intro to 5G and Cloud. I guess it's really targeted at people who are in telco, wanting to know more about 5G and cloud and haven't touched it yet. It's open to software developers who might be looking for opportunities, and there's plenty of opportunities with this. And it's also open to people in other verticals. You might be out there in things like agriculture, ports, industry, and you want to know how 5G and what it can do for you. Anyway, I'm Paul Graham. I'm Director of UK Engineering for Matrixx Software. We're based at Martlesham Heath, Adastral Park, here in Ipswich and Suffolk. So I welcome across from all over the place. We're famous for Ed Sheeran, Adastral Park, BT's Research Centre, Bobby Robson and Alf Ramsey and Ipswich Town Football Club. We're hoping to do better over the coming season, and the Cardinal. And also, just down over here is actually the River Orwell. And not too many people know that George Orwell actually named himself after the river. And he's always topical. He looked on the banks of the Orwell and looked across and said, I'm going to name myself after this spot. So George Orwell was named after the River Orwell, one of our favourite sons. Okay, so if I can move this on. There we go. So the agenda really is, the evolution of 5G. We talk about how we got here, a bit about cloud native computing. What does that really mean? Edge computing, IoT, AI, and I'm making this broad, and we're going to talk about possible application in Agritech, which actually is very popular here in Suffolk in the UK. You might have studied on your geography when you were younger. We are famous for our arable farming. One of the world's most intensely farmed places, actually, if you know the farmers around here and farming. Actually quite interesting. And I'd make a prerequisite to what's coming here is actually what's Clarkson's farm. Despite the frivolity of Jeremy Clarkson, actually that's interesting. And it's quite interesting to see how some of this stuff could be applied in those environments. So in telecoms, we have periodic sea changes. There are some of us, my father was in telecoms, so I remember the move to digital switching. Pioneer here actually at Martlesham. Optical transmission, again, a big player at Martlesham Heath, BT. I came into this in centralized core control and IN, that's fixed line back in the 90s, which got used into mobile, GSM, analog mobile, roaming mobile, and then in data, mobile data, I thought that was a massive step that introduced the smartphone, and with Apple came in, and now we're heading into 5G and cloud and O-RAN and those things around it. And it is quite a significant step in the industry. And I'll explain why I think that is throughout this presentation. Right, all you professionals in telecoms know what this diagram looks like. And the point of it is a telecoms network is made of lots of pieces of equipment. Over the years, you might have started off with appliances. Back in the day, we would have even built our own hardware and software. I worked on a system at BT where we built the whole lot. Over the years, we've moved on to commodity platforms, still with software. And we know the pain this brings of having to upgrade all these systems. And it kind of stifles innovation in telecoms. We know the stories. If you want to do a transformation, it can take months. You leave it running, you then have to do upgrades. Upgrade projects take a while. You then leave it running for years. This stifles innovation, right? Telecoms doesn't move that quickly because the amount of time it takes to do the upgrades, install new systems, and just move things forward. So a typical telecoms network, you have all these components. This is not even touching the service of the things you have. I'm just giving the scene that you have a lot of components in a telecoms network all running in data centers on their own hardware out there. And these will need to be maintained, upgraded. Why 5G? Well, biggest change in our industry since, they say, mobility, 1G, because it's complete transformation. It's putting in the cloud, it's moving containerization and Kubernetes, it's new radio, and it's open RAN, radio access networks. It's a complete change of everything. This will take time. It's going to introduce new way of devices. It's not just about smartphones anymore. It's about everything. It's about our environment, next generation services, and new architecture in the radio and the packet call. It's a complete change, and it's going to take a long time to get there. It also introduces web-scale technologies. Now, some of you from software will say, well, web-scale technologies, containerization, CI/CD, that's old hat. But we're reintroducing this in the telecoms because, for those reasons on the previous slide, we want to increase the rate of change in telecoms. We want to make it easier to manage and just be able to do things quicker and have everything managed in one place. So, and aligning network and IT. I've always worked in networks. However, I find myself in the kind of the charging and BSS space where we straddle in IT as well. And we want to try and bring networks and IT together with a similar sort of ideas and systems. There's always a fight at the edge here where I've sort of been for a while now in charging. Charging controls a network, controls the calls and data, but it's also going into the back-end systems, charging into billing, into those sort of things. So we want to try and bring this together with common processes. I'm going to briefly introduce cloud native here. I won't do it justice, but as part of the story, we kind of need to define what actually is cloud native. And I looked for a good definition of what is the cloud. And in this context, I felt this is the best definition because on-demand availability of computer system resources, data storage, computing power, without direct management by the user. So you're putting it into your clouds. The clouds don't have to be public. They can be your own hardware managed there. The point is, if you containerize your applications and have them under orchestration with something like Kubernetes, you can put them wherever you want. You can move them in and out around the public clouds as you want to. And then it becomes a kind of more about economics. Where is the best place to be running your applications? Which clouds, which environments? And that's what this is all really about. So when people think cloud, they may think AWS, put it out there. A cloud is more like an environment to run your applications in. And it could be your own private cloud, or it could be a public cloud, Google, AWS, Azure, etc. So what the definition of cloud native apps? Well, if we take all this into consideration and look at the 5G standards, they kind of based around microservices, RESTful APIs. It's interesting now, if you've been in telecoms for a long time, you'll remember SS7, then you moved to SIGTRAN, Diameter. Now a lot of those interfaces are now RESTful APIs. Putting them into containers, the application into containers for management. The container app environments are managed by Kubernetes for orchestration. And then once you've got it in container and orchestration, you can put it into a CI/CD pipeline where you're testing as you would be deploying. And that's the point in telecoms. We want to be improve our testing and improve this rate of change and the way we push out our applications into the environments. Then they can be deployed in public or private clouds, depending on your choosing. Containerization of software. Again, I'm sure people out in the software world are saying, oh, yeah, containerization, been doing that for a long time. Well, say in telecoms, we've gone through this journey and say we may be pushing out things as appliances, the packaging. I bet people can remember installing packages on machines and building up the environments yourself. Then they went to virtualization, VNFs, where you're shipping the images. And now we're moving to containerization, where it's CNFs, container network functions. And that's where we'll be doing a lot of this work. And the containers can then be installed in these environments and managed by Kubernetes. I just saw a comment, SS7 is still active in use. Yeah, I've just put SS7 and Sigtran into a containerized environment, actually. That's my background and it's covered my entire career. Right, so Kubernetes, it originates from Google managing large-scale containerized web apps. It was originally called Google Borg, renamed as Kubernetes, and it's the Greek word for captain. Actually, also the etymology for cybernetics comes from Kubernetes as well. So there is a bit of a relationship between Borg, cybernetics, and Kubernetes. It's got the 7 spokes in the symbol because it's 7 of 9 from Star Trek. These people have some humor. And we're now using that as the main sort of container organization platform in telco. So the container organization of Kubernetes, we're deploying our workloads into our clouds. It's doing the scheduling, resource scaling, and the healing in HA of some of the things it does. There's lots more things going on, but we're setting the scene of why we're using this in 5G environments. A bit about Kubernetes clustering. So a Kubernetes cluster, you have nodes. These can be VMs or machines, and you're managing all the Kubernetes environment is managing these nodes and deploying your pods and your environment from a central control plane. That's why we have Kubernetes as a layer to manage the applications in containers deployed as pods. Go on to the Cloud Native Foundation website if you want to know more about Kubernetes and these concepts. It's very good, it's all out there. The minimal kind of thing that's deployed is a pod, and within the pod you can have one or more containers, and the containers can share networking, data volumes, and resources. If you remember things like clustering, it all works or nothing works, and we know we treat them like cattle. They're not pets. If something goes wrong, we kill it and we start again. That's the concept behind this. I guess there's disputes about whether that really does work, but that's the idea. If something goes wrong, you start again and you redeploy it. With the entire, everything depends on everything else. If one thing's not working, then everything's not working, and you kill it and start again. So what does 5G bring? Of course, it brings bandwidth, and we'd expect that with every generation of mobile. It also introduces low latency, and now every generation we're told is wonderful mobile. However, if you get your phone and you do a speed test on your Wi-Fi, if you've got good connectivity on fiber, you'll get about 4 or 5 milliseconds. If you go onto your mobile network, you'll get about 40 to 50 millisecond latency. And that is not good enough to do control applications. It's good enough to stream video. It's good enough to listen to music. It's good enough to go on websites, but you will not get any real time on those kind of latencies. So the point of 5G is to kind of bring everything down, employ better radio, put the applications with the network functions, and improve latency to the point where you can use it for control applications. You got slicing. Slicing is effectively a kind of quality service where through an entire layer of the network, from radio to the systems, the transport, you give a certain group of things certain levels of QA. Now, you may have thousands of IoT devices, doing temperature sensing, which don't really need much guaranteed bandwidth or latency. And you have a slice and you give them a certain quality of service. Or you may have self-drive cars, which need the best bandwidth and latency. And you give them a slice which prioritizes all their traffic. You also may have a network such as, Vodafone network, and some of you may have come across MVNOs and give them a kind of slice on somebody else's network. So that makes, that's what slicing is. It's a new concept and will take time because it relies on things like guaranteed radio and guaranteed systems. New radio technologies means high device density. Try going to a football match or a concert or in a center of a city, and using your mobile, you get lots of issues because it's not really up to it. But the new radio technology means you can have a higher device density. And also that it's a combination of the higher frequencies, smaller cell sites, and radio. Again, I've said it, technology is based on cloud native and web scale. Again, people in software will say this has been around for years, but this is now introducing it into telco. And with 5G, we're replacing CNFs with BNFs. So container network functions with virtual network functions, as we've highlighted before. So 5G is more than just faster speeds. It's about it's massive IoT. It's ultra low latency for industrial applications and enhanced mobile broadband. And enhanced mobile broadband was one of the earliest usages of 5G. A lot of the earlier trials in the UK was, not sorry, UK, the US, sorry, home broadband, where it's difficult to deploy cables or it's cheaper just to put in the radio to provide enhanced mobile broadband. And that was one of the applications. Of course, anything that requires high bandwidth, low latency is an application. So industrial automation, self-drive cars, gaming is a big one, and UHD media. However, I'm a bit skeptical of media because, when you talk about music and videos, your latency isn't so, it's more about bandwidth, right? It's not about latency there. But yeah, these are the range of applications. And of course, we're building a platform that people come up with new ideas. Just like when they introduced 3G, you had your brick phone, didn't really do much. Then Apple came in and had the smartphone. Then 5G will lead on to something new, which people probably haven't even thought about or are working on now. New concepts and new ideas. So bringing this together, it's interesting. We have a picture of Patrick Stewart as a Borg today, just after William Shatner went into space. Maybe Patrick Stewart will be the next person going to space at SpaceX. Anyway, harnessing, so the sort of things we're harnessing, yeah, it's all about cloud native principles on commodity hardware. Yeah, somebody just pointed out we have a line on the screen. I don't know where that's come from, so I'm going to clear that.
I'm just trying to fix it, Paul.
You got it?
No, not yet, but I am trying to.
I think it's clear annotation, I'm being told. Okay, so I'll carry on. We'll try and clear the line. So I'm leveraging cloud native principles and open hardware. Distribute everything. That's the point. You have your applications containerized. You can put them where you want. You can put them near the applications to get the improved latency and control of the systems. It's about independent scaling of the applications. So you may have box standard telecoms kind of control, which you don't need too much power on, but then you may have applications like self-drive cars, where these control systems need to be deployed everywhere over the system and into the edge. Self-healing and using the Kubernetes and the cloud native stuff to do the port isolation with and HA and distributed recovery. And everything's driven by APIs and automation. Now, okay, so this is what a 5G network architecture looks like. If you're new to 5G and being in telecoms, yes, they've rewritten all the acronyms. Like SMS used to, it's a packet gateway, and GGSN owed money. It's now a session management function. You've got the advanced mobility function, PCF, your policy control, SMSF messaging, network exposure functions, NOF network. You've got what that one is here. UDM, unified data management, effectively an HLR where you store your data. So it takes a bit of time to readjust to the new, but mainly you'll find if you're implementing technical stuff, then yes, things mostly map on to the old world, or can be made to fit into the old world. Yeah, I'm seeing a comment on here. Yes, the new architecture, new protocols is more friendly towards deployment in kind of web-based environments, right? I involved in charging. Charging is now CHF charging function. It has its own interface, N40, in this environment. I've been in IN, so I've been used to control plane and user plane stuff in the whole of my career. But this is getting more towards the separation of the control systems to the user plane, which is your data. And the idea is each one of these is a network function, and they are containerized and deployed in the cloud native Kubernetes environments. Yeah, I'm seeing some other stuff, so you don't necessarily need Kubernetes, no, but you are containerizing these functions and using REST interfaces. As somebody said, interesting thing on SCTP just come up actually. Yeah, interestingly, we still have to put the old world into the environment, and we have spent a good chunk of time putting things like SIGTRAN into containerized environments with Kubernetes, with all the issues that come around that, multi-homing, multi-pathing, but I'm getting too technical there. The point is, the 5G network architecture has all these network functions. They're now containerized. They have REST-based interfaces most of the time. There's still some legacy interface in there, and we can put them into the cloud. And that means you can also, it becomes accessible. You can have your own private networks. You can have your own private radio and have your core hosted in the cloud, or you can have both the control plane and user plane in the same place. So the main emphasis here is the main systems of 5G are deployed in the cloud. And if you go back to one of those first diagrams I had, with all those boxes of packet gateways, MSCs, Node Bs, and all the rest of it, they all are distributed across the network in their own hardware. Here we put everything in containers and put them into the cloud. The idea is you can build pipelines and have a more rapid cycle of innovation, upgrading. That brings on, people hear about edge clouds. Well, the point there is, your box standard mobile service, which is voice and data, maybe still centralized, but you then may have to put stuff on the edge. So you can deploy these things in the edge on edge clouds in those environments. But once they're containerized in Kubernetes, you can put them where you want. Whether in data centers, or you have a private network dedicated to a stadium, or you're off doing your own, a specialized sort of sensing environment that you need, which made it a dedicated core. Time that, okay, we're doing well. What does this lot bring? Well, it brings all sorts of new ideas, and this is just really to shake things up. Augmented reality, where you've got real time and you've got low latency, so you might have extended reality going on. Trust. Does the environment identify who you are? Is there so much things everywhere that they can see you? So like Minority Report. Immersive interfaces become part of the environment. Design concepts, digital reflection. I guess everybody's collaborating together in their virtual worlds for design. Working autonomy, industrial control. What about because you've got low latency and high bandwidth, and you may have your own private networks. I know in Germany, the industrial companies over there, the manufacturing, are investing heavy in private networks, so they have control of their systems and monitoring, because it gives them that kind of security and guaranteed access. Yeah, so there's probably lots of use cases we haven't come across yet, but you've got to be thinking high bandwidth, low latency, can deploy your own network, private network, wherever you want it. I know. Right, how does it compare to Wi-Fi 6? That's the 2 slides a couple ahead. Opportunities, develop low latency apps deployed in cloud infrastructure as a 5G core. You have a 5G core, you can deploy your apps into the same environment in the cloud as the mobile network. So you improve latency. One of the things we did with mobile, we centralized everything in all network data goes through centralized points. We can now open it up again. So you can have your own core and SMF and user plane type functions to improve latency. Industrial control, all the standard ones they talk about. However, I think somebody needs to be creative and come up with something a bit new. I've got a new platform, augmented reality, industrial control, gaming, autonomous cars, private 5G networks, and really think beyond smartphones, because you're not limited because of the high device density. You can have lots of things 5G enabled. So things in the environment are wearables. Why 5G for IoT? So moving on to IoT and just to complete the things. Okay, so you can have masses of devices. 5G radio permits high device density. Try putting out millions of thousands of devices in the environment, all on the same radio network, same cell. You have problems. I think in 5G, in mobility, it's always secure. People trust it more. It's high bandwidth, private 5G, and monetization. And that's another important thing. Monetization with charging and billing is always built into a mobile network. And it's always an afterthought. People come up with their cool applications, but they always forget how you're going to monetize it. And monetization is built into this. And if you have monetization, you've got to have trust. You can't be overcharged, undercharged, or any fraudulent behavior. So that's a key thing of mobile networks. You have monetization and trust built in, which you probably don't have in other types of networks. Wi-Fi, okay, so we do have competing technologies. So we'd say in the UK, it's horses for courses. I mean, if you've got lots of temperature sensors out in fields, just periodically sending back temperature, then you're probably looking at lower band type technologies, wider range, lower bandwidths, low energy. Wi-Fi 6 is in there, but I think Wi-Fi has been killing off. They say Wi-Fi has been killing off mobile for like the last 30 years, 20, 30 years. It never has. They coexist as a technology. Your mobile provider will quite happily give you access to Wi-Fi networks because it's good for them. It gets you off their mobile networks. And at home now, it's quite common that you can make Wi-Fi calls on your Wi-Fi networks. And previous generations, probably not so much previous generations. But you also want to reuse. Got somebody on there. The noise coming through. Like previous generations, you always want to make the most of your previous investments. So you're going to use 3G and 4G as much as possible. Okay. What are the threats to 5G? Cost of deployment. That's a lot of radio you've got to put out there. Energy usage. Energy usage at the moment is quite high, but maybe that will come down with innovation. And yeah, the cost of putting 5G into devices at the moment, well, it's still going through its innovation phase. Okay, as people invest more and the research happens, then the costs come down as it gets written off. Yeah, there's some very good comments going on through here actually, which is sport line. So yeah, I advise everybody to read the comments actually. Yeah, low RAN beats new radio in terms of energy consumption, absolutely. Ability to trade off between bandwidth, power range, latency. Yeah, agree with all these comments coming through. So thanks for that. Now moving on to artificial intelligence. So yeah, 5G has absolutely nothing to do with artificial intelligence. Yeah, that's correct. But it's a platform of which you can put on top your applications that use AI. There's several ways that AI is associated with a 5G. There's kind of AI systems in the networks to predict patterns and make adjustments. That's one thing I see. I mean, yeah, you can implementation of 5G networks has nothing to do with AI. However, it's a useful platform to deploy AI type applications. And lots of misunderstanding. AI is bound about all over the place. So AI is about having a model of something you want to do. You want to do some training, so you put the data into your model. That's all going to be on some servers somewhere. Maybe the 5G network is applying that data. That's what it's doing. You're testing your data, and then you've got inference on the edge. So you've got devices out there that might be deploying the models too. You might need some bandwidth there to deploy your AI models to do inference. Like if I was to say, it's like Alexa. Alexa has something built in as wake up. So I go, Alexa, how are you? And Alexa identifies a wake up, but the rest of the processing is done in the network. And that's what 5G lets you do.
Here's something I found on the web.
There you go. So Alexa's kicked off now.
You simply have to enter the desired MAC address and the program does the rest.
There you go. Alexa's kicked off there. So that's what really it's about. It's a platform on which you can build AI systems, but 5G in AI are really, it's just like another platform to build things on. Yeah, everybody's had theirs triggered now, haven't they? Always do that. Okay, so the final application, as an example, the point of this original talk was bad in Suffolk here, and we have lots of agriculture, and Clarkson's farm is quite current and everybody's enjoying it, but there are some very serious applications here. In Agritech, you have sensing, you have industrial control, you do have combining, you have plowing, you have drilling, you have spraying, all going on. All this could be automated, and it is, and that would rely on, gives you good coverage across the fields. So harvest prediction, that's a bit of an AI thing. And we know from watching, again, Clarkson's farm, it's all about predicting the harvest. It's very important to farming, and the more better they can get out of that, the better their crop and the harvest will be. So that's a serious application. You could put sensors out there to detect things like moisture, sunlight. You can even have things on the crops to detect what's going on, and then you can predict harvest. Yeah, crop management, drones. So yeah, you can have spraying and monitoring of your crops using 5G. So actually, I think 5G is quite a good. Agritech is a good example of the use of private 5G networks. It's all there, and it's something we can relate to. You want to be very careful when you're running machinery like this, and 5G and the control systems required. Yeah, it's all good stuff. Yeah, got a comment here. Yeah, combination of 5G, new radio, and LoRa hub. Yeah, totally agree with that. That was kind of my point. Yeah, you've got the low bandwidth sensors out in the field, like the weather, the rain detection, sunlight. You don't want to waste 5G resources on that, and that's out there. And the rest of it, but you've got combining and you've got drilling going on, and you want that to be on 5G. So yeah, good points there. So the final thing I've got is a platform to realize on this. So, you've got your AI applications in TensorFlow deployed in your Kubernetes environment, along with your 5G core. You want to put it in a public cloud somewhere, so put it in AWS. You're going to connect in with 5G to your applications. So you've got your drones doing your spraying, crop monitoring. You've got your combine there doing combining out in the fields. Sorry, that guy on Clarkson's farm forgot his name, but after he's been doing it 50 years, he's going to be replaced by automated combining. Maybe that'll be series 3 of Clarkson's farm. And you've got your weather sensors pushing everything back to your AI to try and predict harvest. I wouldn't say you ever replace a farmer, but you could augment a farmer with more information. And I think that's what this would bring. So bring it all together. This is your application for 5G. Deploy your private network, get it covering your farm, and then you have your control applications, which is all very topical at the moment, right? Labor, more automation, and food security, especially in the UK, with the supply chain issues. So rounding off, then yeah, we got 5G, which is the latest evolution of mobile. It's designed to be deployed in the cloud and container environments, such as Kubernetes. However, it doesn't have to be in Kubernetes. It can work in the cloud. It has competing technologies like LoRaWAN and Wi-Fi, but they always coexist. Nothing's going to knock anything else off because they all have their place. LoRaWAN is going to be low bandwidth, low energy, wide coverage. 5G is secure, monetized, and trusted. And Wi-Fi is always there for us. And yeah, my message to people is go out and take those opportunities and fill your boots. Plenty of work out there. The network is still being built, so there's opportunities to, go out and get your 5G startups going. Lots of government money in O-RAN at the moment in AI. Go on the government websites and you'll see the studies and the investment going into AI tech and O-RAN. That's the biggest one at the moment, I'd say, as well. So lots of opportunities. And with that, I bring it to an end. And questions. Now, what I can do is just go through and see if there's any questions what we can put out. Yeah, I'm just going through the comments. What do you think Clarkson's opinion on 5G would be? Well, now it doesn't cause COVID anymore. He'd be amazed by it. Yeah, definitely season 3 of Jack Clarkson's farm is going to be Clarkson totally automates his farm using a 5G private network. And Jeff, and he puts it onto AWS. I think Jeff will approve of that. What else have we got here? Oh, I'm just looking through the comments, actually. Excellent comments. Yeah, got in the spirit of this. I don't see any questions, but I do see a lot of discussion. We need to capture that somehow. Yeah, just yeah. SCTP, I said, been working on that. It actually is now going into Kubernetes 120. Got some of that going on. Yeah, I got Thierry's making comments. Yeah, good experts in this field. Yeah. Yeah, it's VNFs to CNFs, if that was misunderstood. Yeah, you can certainly use these stuff for previous generations of mobile who want to. Okay, then, I mean, is there any other comments people want? I think what I see from the comments is actually people have engaged and some really good stuff there, actually. We're recording it for future, but what we'd like to do is better create a series of these. I mean, there's other topics which I think are quite interesting to people in the profession.
There's another question just popped in there. I don't know.
Yeah.
There's a few more going in. Just
okay, I'm checking. Got it. Right, well, Thierry's got one. What is the mix going to be between public and private 5G networks? Well, any opinions out there? Is there anybody working on 5G networks at the moment? Or any kind of interest?
Feel free to unmute, guys.
Yeah, if you want to answer that and unmute, then please do. There's something an answer. I think private 5G is limited on spectral access, but there is a band dedicated to 5G private networks. It's got a specific.
Not one band, it's a whole series of bands. You can either use shared access spectrum, which 4 different bands, band 3, band 40, N77 and a millimetric band, or alternatively, you can go for local access licensing, where you can get a secondary license on any of the primary mobile bands that are not being used local to where you are. Yeah, and we do both.
Yeah. Do you have good examples, is that James, of deployments at the moment?
Yeah, we've deployed both 5G non-standalone and 5G standalone networks. The non-standalone are kind of casebook deployment. There is 5G non-standalone in the Chalk Valley, southwest of Salisbury, which is part of the DCMS 5G testbed and trials program. Yeah. So there we're deploying a 4G waveform as a 5G NSA anchor channel, which provides a basic mobile telephony service, so 2 megabit per second profile, combined with a 5G new radio waveform, which runs an ultra-fast broadband service at 100 megabits per second. So that's the rural one. And then our main urban one is Liverpool 5G, which is 5G standalone operating in N77 on lampposts with 60 gig wireless mesh backhaul.
Is that a trial, or is that for like mobile broadband then?
No, that's principally for community health services.
Okay.
In central Liverpool. So it's a total of about 70 or 80 nodes in that one, covering an urban area in central Liverpool.
Okay, yeah, thank you. That's interesting. Well, I've got there's a question here. Can you share thoughts on how CNF is directly driving the Telco Evolution, or is it just 3GPP, just adopting, proving cloud concept of standardization? Yeah, I expect people have opinions on this as well. my opinion at the moment is telco is kind of at the first step of putting everything into container CNFs and deploying. And the evolution of that will be like pipeline concepts and pushing things out quickly. But we have a lot of investment in telecom as well, a lot of applications that's from previous generations that need to work. And I think the challenge at the moment is getting those moved forward. You still have to do voice. I mean, that never goes away. I started my career in the mid-90s and everything was going to be VoIP then, and normal telco was going to go away. I think normal telco will go away and voice at the end of my career, probably another 10 years time. So my entire career will span from voice is going to go to making a career out of it to eventually going with me, I think. That's quite a long time. These things just take a long time to happen. And I think the first step is CNFs, deployment in cloud, getting the 5G concepts working. That's what we're doing. I mean, we're pioneering that in Matrixx. We do have places where we've been doing this, getting them out there. And then they're moving it to more rapid evolution and more. So they define the 5G core in the cloud, but you want the apps to be in there as well. I think that's the next step and where the opportunity is. Is 5G just another G? Thanks, Robin. It's evolution, isn't it? It's always evolution. You know, is it? And basically, this is pushing things forward because it's that point in the investment cycle where things are changing. And we see that happened over the last 20, 30 years. And we need to we're moving to different technologies. And, you know, that's what's happening. And we call the next evolution another G. And that's what it is. It's healthy for us. It provides opportunities. We do need to see better telco networks. We do need to see them more reliable, or rather better coverage with higher device density and those things it brings. And we need to better use it more out there for our applications. So that's what 5G brings us. It's the next step.
Paul, Thierry, if I would give, you know, my top reason to go for 5G, it would be spectral efficiency. Yeah, what's the amount per second per hertz that you can convey? It's like, how high can you build your house on a plot of building ground, right? And if you have stronger materials, you'll be able to build a skyscraper. However, if you only have wood, you'll be limited to a couple of stories. So it's really this. We have a limited amount of spectrum out there, especially low band spectrum that goes deep indoor, right? It's quite scarce. Yeah. And so we need to make the most out of it. And the UK has been withholding the licenses for the low bands. I don't know what your opinion on this, but it's in these low bands where operators will only get 5 or 10 megahertz of spectrum that they will need the 8 bits per second per hertz that 5G provides versus 3 bits per second per hertz that we have seen on 4G up to now.
Yeah, I mean, I agree. I think that's what it's all about, right? Getting more efficiency, improving the overall coverage and improvement. I mean, I'm not an expert on radio, so I'm not going to go there. I just know that's kind of concepts. I've always worked in the application space of mobile, but I think that area deserves its own discussion. So that's maybe something we can do in the future. Basically, yeah. Anyway, thanks for that, Terry. Got an interesting one on charging. That's what I do. Yeah, well, I do real-time charging, and that's what we need to move to, right? We're still weighed down by we're weighed down by the old batch system too much in mobile, and we need to move to the rapid real-time monetization concepts that you see when you're experiencing purchases on other things. I won't be too controversial here, but I know even the competitors on this call will agree with me that we need real-time monetization and charging. Still too much of stuff is legacy, it's OBSS, and it's batch-based, and you get a bill at the end of the month, you don't really know what you're spending. This is where the telcos need to catch up with the new world on the internet. Fundamentally, you buy more stuff if you trust it, and you can make micropayments. It's that simple. And in mobile, we're still on the old, 2-year plans, billing bills at the end of the month. And we need to make billing and monetization something that happens now. And we need everybody to be able to hook into it. Everybody should be able to charge for your telco bill or charging model. And I think whoever you are on this call, you agree with me on that. Like, I know there's all sorts, but that is one area where we're going to agree that everything needs to be real time in the charging space. And that's how mobile is going to increase its value. Right, so let me see what else is here. I'll just take one more. There seemed to me what we would call the OSS model world of performance management, but where's the fault management aspect, and do we need it? Or yeah, okay, that's an interesting one. OSS and fault management. Well, we hope it's built into the observability of the Kubernetes and containerized environments, the alarming and that sort of stuff, right? That's what we know by OSS, the management of the systems. It is built into Kubernetes environments, and that's where it would be in terms of OSS, deploying software, monitoring it, and the observability. And that's what I think that's moving to. You say fault management, yes, it's absolutely paramount to a mobile network. Anybody running to know exactly what's going on in that network. And the technologies do have the necessary adjunct systems in there to do that. There is, and that had to be built into the more traditional OSS models that we're familiar with in order to monitor these networks. Okay, then. Yeah, I'm just rushing through. I think we've actually covered a good area. That brings us to the...
You've got to come to a natural conclusion, Paul.
Yeah, I think we've come to the natural conclusion. That's the top of the hour. So thanks everybody for turning up. It's been very interesting. The comments are great. I've been reading through them. Real engagement here and good experts feedback on the call, actually. So great work, everybody. I hope we can sort of continue this in the future. So back to you, Sam. Thank you.
Yeah, sorry, I'm busy dying in the background. I've popped in messaging. I popped in twice in the end. So we've got two things. Firstly, that we've recorded this session. I'm so sorry. We've recorded this session and we'll edit it and make it live tomorrow. So we'll share it with everybody. We've got a LinkedIn chat attached to the group, and we've also got Meetup. But if you came at this through somebody sharing the Zoom link with you, if you want to send an email to Sam at Measured Brilliance, we'll happily share the link with you. On top of that, we work with Suffolk County Council. We're very lucky and very well supported by our local councils and LEP. And we've got, after next week, there's a hackathon at BT next week for some students. And at the end of it, we're launching a thing called the Innovation Race. So it is a hackathon, but not a hackathon. So the idea is it's a sort of hack that lasts for about 3 months. It's fully remote. So if you're international, and as long as the timelines work for you, we'd love you to join in. We haven't announced the prize fund yet. That will be announced later next week. But in Norfolk and Suffolk, across the last couple of years, will have deployed soon 220 LoRaWAN gateways, which makes it the largest free-to-use network in the world. And everybody's quite interested in tech innovators making the most of it, and particularly students and getting involved. So we have a creative computing club. They're going to make the most of it and have a team. We've got some newly launched IoT A-levels and some data science courses, and the students are going to come from that. But we would love to have grown-up teams as well, or anyone else come and join. So it's open to everybody from next week. So again, if you want any details about that, if you send me direct an email at sam@measuredbrilliance.com, or connect with me through LinkedIn, or sign up for updates through any ISTN channel, you'll get access to the innovation race, courtesy of Suffolk County Council. And we've got more stuff like that coming. So one of the nice things about Suffolk is we've got an incredible community. It's getting more buoyant. COVID's been a bit of a win for us, sadly. It's getting more buoyant all the time, and we've got more events coming your way. So sign up any way you possibly can. And the idea from us is you get a curated list of things that can populate your month nice and easily. Pick what you want to book and you can sit back and relax. So there we go. But thank you so much for coming. We really appreciate it. As Paul said, it sounds to me like you've definitely got some experts on here that we should have some sort of panel event going forward as well. I think stimulating some conversation would be great. And we've definitely got lots more telco talks and 5G, etc. talks coming our way. So thank you to Paul. Thank you to you all for attending. And thank you to the ISTN board who support this with us. And we will be back very soon for some future talks at the ISTN. I'll drop the link in as well so you can check there. Okay, everybody.
Great.
Thank you so much. Thanks for coming. I'll end the call.
Yeah.
Thanks a lot. Bye, Martin. See you later, everyone.